100% net zero. Yesterday, CII, two buildings got award. They got about 75% of the energy being generated there, zero liquid discharge. It's a very nice award. So therefore, the near zero is also coming very well in a large way. Okay.
Rupesh, if you can have that headphone, yours is a lot of echoes around. If you can use headphone.
Is there an echo?
Rupesh, yeah, that view is better. ಸ್ವಲ್ಪ ಮೇಲೆ ತಗೊಂಡು you can be closer, and also if you can use headphone, we'll have a lot of clarity on that.
Yeah. Maybe ask Bhavani Prasad ji, the camera can be a little there so that above the head is more, and he is at the bottom 1/3.
The headphones, Dominic?
Sorry, Rupesh?
You think the headphones will work better?
Yeah, for you, headphone will work because there is echo.
Oh, okay. I'll just get it.
Yeah. So we are live now on YouTube. So I'm going to begin in the next couple of minutes.
84.
Sir?
Okay, is it better now? Can you hear me?
Yeah, better.
Hello.
So let's begin. We're late by 8 minutes, so we will kickstart this 11th webinar on various subjects. We have covered on evacuation, we have covered on emergency, why audit is required. We covered on artificial intelligence. So this is for the first time that we are talking about energy efficient building, net zero building. So I am very proud to present to you our dignitaries here. We have our keynote speaker, Mr. V. Suresh. V. Suresh is the Vice Chairman of the National Building Code Sectional Committee and Chairman of Housing and Planning and Prefabricated Construction Sections Committee of BAS. He is also Chairman of Indian Green Building Council. And is a member of CAA National Committee of Real Estate and Housing, member of Indian Merchants and Chamber of Real Estate and Infrastructure Committee, former Chairman and Managing Director, Housing and Urban Development Corporation, called in short HUDCO. So I welcome our keynote speaker, Mr. V. Suresh, to address this gathering. So once he completes, then I move on to the speaker of the day, Dr. Rupesh Iyengar. Over to Mr. V. Suresh.
Okay. Is my voice clear?
Yes, sir.
Wonderful. A very happy good morning to you, ladies and gentlemen, and all the distinguished participants, and to you, Dominic and Dr. Rupesh Iyengar, the star performer for the day, and of course, the distinguished presence of Bhavani Prasad ji, former Director General of the CPWD and Chairman of the National Building Code, part on electrical installation, and all you delegates. It's a great pleasure to be talking today on the topic of net zero energy, where a detailed presentation will be coming shortly, and for me to give some opening remarks on that. India is at per capita energy consumption only around 1,181 kilowatt hour per person per year, as against US is about 12,900, about more than 12 times bigger. Even global average is double of this, 2,674. And building sector contributes to more than 30% of all the energy needed, and the remaining component by the other areas. And India is generating around 3.71 lakh megawatt of energy for the whole country's need, of which renewable energy is around 87,000, and the thermal and the other one comprises 60%, 62%, and nuclear hydel energy separately there. And this is an area where we are trying to find out how energy use that's required in the building is optimized and efficient in a large way. So the concept of energy efficiency has always been part of the Indian Green Building Council's larger ethos, wherein a saving of the order of around 35 to 40% of energy was an important component in all the rating system. So in green building rating, about 26 rating system we have for offices, hotels, hospitals, residences, factory buildings, retail malls, etc. 26 rating. In each one of the rating system, energy efficiency is a very important component. So therefore, it is at that particular context that in the last about 20 years time period, we have come a long way. We are number one with over 92% of the India's green building rating. And today we have a very happy situation of 7.55 billion square feet of green building. That means 755 crore square feet of green building through nearly 6,000 projects all over the country. And all of them are saving energy in a very, very large way. And the impact of that particular thing can be seen that the energy saving component that has been coming through the HUDCO projects, IGBC projects of 8.71 billion units of energy per annum, which would be around 1.7 crores of village households can be electrified with that. 8.71 billion units of kWh is a phenomenal area that's coming in that particular area. And even carbon footprint reduction, about 8.1 million tons, which would be around 9.1 million cars off the road. So that's the type of impact that we have been able to. So having done that, we took the next major level in 2018, 2 years back, to bring in one of our important rating system. As I said, we are 26 now. So this rating system came in 2018 called the Net Zero Energy Buildings, which was launched during the Green Building Congress 2 years back. And it's been also aligned with the World Green Building Council in a very large way. And net zero energy buildings are those that are designed to have lowest energy demand, high energy efficiency during its operation, and thereafter its energy requirements are met with. We are also able to see that beyond energy, renewable energy component, we are also able to give back to the grid. Net positive also can come in a large way. And very popular by the industry, by the builders, developers. Over 10 projects have already come up under this net zero buildings, and some of the very, very important building of office building, ITES, parks, factory building, warehouses, hotel buildings, etc. are very, very important. And we are happy that some of those initiatives done by Godrej and Boyce, ICICI Foundation, and other agencies, Capgemini in Bangalore, you're in Bangalore, are all important projects. And these projects are ready to reduce the energy by deploying energy conservation measures of a very large nature. And it's a very important, significant how they do that particular one. And it's a combination of effort that we do by utilizing the both the passive and the active component of energy, passive through orientation, the envelope design, active through energy efficiency, including renewable energy, energy efficiency through the air conditioning system, lighting system, auxiliaries, appliances, etc. And the renewable energy through on-site renewable energy as well as off-site renewable energy. So it's a effort that has been done in a very conscious way. And in the net zero energy system, we give weightage for energy efficiency related component around 75% weightage, and the weightage for renewable energy of the order around 25%. And therefore, it will be very interesting to see how we are able to do it aligned with the Energy Conservation Act, Energy Conservation Building Code, the National Mission for Enhanced Energy Efficiency called NMEEE, and this is all part of the National Action Plan for Climate Change, NAPCC, and as well as National Solar Mission, aligned entirely with all these initiatives which is coming over there. And net zero energy rating has facilitated the installation of nearly 2,000 kilowatt power of rooftop solar PV system, which would generate about nearly 3,000 megawatt hour annually. Wonderful. And wheeling of off-site renewable energy has offered opportunity to reduce significant operational energy cost also. And net zero energy certified projects are wheeling green power equal to nearly 12,000 megawatt hour annually. So what are the challenges that we have? And it's already catching up well. So one is non-availability of energy use benchmarking for the building typologies, lack of information technology of RE system, primarily for linking with the grid, restriction by governments on the renewable energy installation, wheeling charges, net metering component, and non-availability of facilitator to provide solutions and strategies to achieve new net zero energy, and limited number of ESCOs which are working in deep retrofitting of HVAC. So IGBC is working for capacity building on green building, MEPF, very important component. For example, if you really go one by one, some of those initiatives are phenomenal. From what we were around few years back, 10 years back, if maybe 150 square feet per ton of air conditioning would have come, we have come a long way. Now about 800 square feet per ton of air conditioning with the latest technologies that we have in the air conditioning system has brought in energy saving by 75% only in the one. And the lighting power, if you only 1.5 watt per square feet in 2003, today we are only 0.6 watts per square feet. So lighting load getting reduced by 60%. Air conditioning system from COP5, we are able to adopt COP8 with chillers, magnetic levitation chillers being brought into a large way, pumps and other related things like condensers, water pumps, etc. are able to, using variable frequency drive as an integral part of design, has also been able to really bring the energy efficiency into a very large. It's an integrated approach with passive and active design, where there's so much contribution which is done by the architects and the civil engineers on ground one in the initial planning, mechanical, electrical, plumbing, firefighting team to bring in all the energy saving measures in their own design, be it lighting component, air conditioning component, all your auxiliary electrical power use, etc. And then the next major thing is to bring in renewable in a large way. How do you integrate the renewable energy component over there? I did tell that we are building around 87,000 megawatt of electrical energy through the solar power, but we are going to double that to nearly around 1.5 in the next about 2 years time. And the solar energy component itself enhancing from the current level of roughly around 34,600 megawatt to around 65,000. So therefore, a major initiative is coming in this particular area. So renewable energy is going to be what was earlier only around 12% of the total energy, will increase to at least of the order of around nearly 20% energy in the next around 5 years time period. And the Prime Minister's recent launching of the Asia's largest solar power project in July 2020, 750 megawatt in Madhya Pradesh has made a good impact already. And therefore, this catching up, not only rooftop photovoltaic integrated ones in the fenestrations, as well as solar photovoltaic banks coming separately if you don't have space in the building, and rooftop. So these are all very interesting components of initiatives being done, and each one is putting their contribution. The air conditioning industry, the refrigeration industry, the illumination engineering, all your pumps and machinery, your firefighting system people on all the equipments to be done. All of them require phenomenal amount of energy needed to keep it running. Plumbing system in a large way for water and related one. Each are contributing to that energy saving component. As I said, it's a combination of effort of both passive and the active design. I'm very happy that Dr. Rupesh Iyengar is going to make the presentation, and Dr. Bhavani Prasad also will be joining. And this is an area which requires massive dissemination large way, and the Indian Green Building Council is playing one of the major roles in promoting all the 26 rating system in general and the net zero energy component in a large way. We are getting in one more step forward. Even though we launched in 2018, that was a pilot edition, and we are going to convert that pilot edition now into version 1.0 with the good experience we had in 2018, 19, and 20 so far. A lot of innovations are going to come based on our experience in the many buildings that we have used the particular application, which I told you, the series of buildings I mentioned very briefly on that. And we're also thinking in terms of not even if you're not able to achieve 100% all energy to come from within over there, a near zero energy component. Net zero is the best, where all 100% energy is produced there and you're able to give it back, which is net positive. But you're also able to give a near zero where renewable can come. Yesterday, one of the major buildings in Chennai got the CA award, where 75% of all the energy required has come only from the renewable energy component. So it's a combination of effort that has come in the effort in a large way. And we would bring it out in the Green Building Congress, the 2020 event going to happen October end. By the time our next version of net zero energy and near zero energy would also be launched. I'm very happy that we have a very distinguished participant. We are all 100 now. I find it shows the type of interest that you have on a Saturday morning on a topic which are where not only the leading builders, the industry from consultants, mechanical, electrical, plumbing, firefighting people in a large way, architects, engineers, electrical in particular, very important, are also putting all their act together in making the net zero energy initiatives a big success. And I'm sure maybe by the time we have another event, maybe 6 months from now, the 10 projects which are already net zero so far in the country would come to at least of the order about 50. That's the type of response that we are able to get from industry all over. And there's a lot of interest generated. They're all eagerly looking at how do you do that? What are the concern area and what requires to be done? Is there any additional cost involved there? Not at all. As a matter of fact, whatever be the marginal 1.2% of the capital cost that you're going to incur for introducing all these features in all the building, you more than make it up in less than about 1 year to roughly about 15 months time period. Your payback period comes because your energy saving is phenomenal, about of the order of roughly about 40% or 45% of the energy saving is coming than your conventional building. And that cost that you have on that is where the life cycle cost is going to come in a large way, which NBC has now put it in the sustainability chapter part 11. And then the new chapter on assets and facility management really ensures that all these system critical utility services are all maintained properly. Assets and facility management also brings in the energy saving, which can also be measured through the building management system. And equally important is when you want a successful net zero energy building, PMS becomes a very important component on that. And therefore the building management system has to play a very important because what gets measured gets managed. And then we were able to measure at each one of the level the type of energy saving that can come over there, and you're able to therefore apply your mind, which can be monitored 24/7 and also bring in the net result. And on that very positive note, I want to say thank you very much, and looking forward to hear young Dr. Rupesh Iyengar for his presentation, and also hear from Bhavani Prasad. Thank you very much, Dominic, for calling me over to share some of my thoughts on this wonderful Saturday morning.
So thank you very much. Thank you very much. That's a very high-spirited speaker, Mr. V. Suresh, the chairman of Indian Green Building Council. I now invite our next speaker, Mr. Rupesh Iyengar. Rupesh is one of the youngest consultant in the country and the gold medalist on the subject. Iyengar is a high-performance building designer who believes in the philosophy and integrated and sustainable approach to the design of the built environment. His company, Service Consultant, is involved in MEP design, sustainable design, and zero energy building projects. Many of his projects have won global awards. He is currently designing various five-star hotels, luxury apartments, commercial offices, and hospitals, and technology and commercial offices across Asia and India. He is a sustainable technology expert, partner with United Nations Environmental Program called UNEP in the Climate and Clean Air Coalition Initiative. He has published two books titled Decentralized Approach to High Performance Building Design in Tropics in Germany by SVH Vergers and Asia Cities Necessity, Challenges and Solutions for Going Smart in USA by Springer. He is also the president of FSA Bangalore chapter. He is also an active member of IPA, ISTRE, and ASTRE at Bangalore. He is the youngest ASTRE DL in the world and is a part of conferences and exposition committee of ASTRE. He has published more than 20 research papers in top international journals and conferences in USA, UK, India, Singapore, Switzerland, Philippines, and Australia, etc. He has collaborated with ETH Zurich, NUS Singapore, Concordia University of Canada, University of California, Berkeley, USA, and Princeton University, USA on various research projects. He is a university topper in mechanical engineering and mechanical of Bangalore University and holds gold medal in sustainability from National University of Singapore. He pursued his doctorate of science in sustainability and zero emission design from ETH Zurich and the Future Cities Laboratory. I welcome young Dr. Rupesh Iyengar to address the participants on net zero energy building. Welcome to you, sir.
Thank you, Dominic. Can you hear me? That's the first thing I want to make sure that. Okay, perfect. So yeah, thank you, Dominic, for organizing this, and thank you, Mr. V. Suresh, sir, for the inspirational keynote. Before, I think you have touched all the pertinent points as to what net zero energy buildings are and what is their importance and how we can actually go forward in looking at more net zero energy buildings coming up in the country itself. So I think we will, I'll just share my screen. I have a short presentation, which I would like to also share and go through some of the details of the net zero energy buildings and then go on to some case studies. So I'll just share my screen. Okay. All right. Is it visible now?
Yeah, it is very visible.
Yeah.
Okay, perfect.
Bold also. Fonts are good.
Okay, perfect. Thank you. Yeah. This will be the learning objectives. These are some things that I would like to kind of share with all of you with my experience and also some research that has gone into it. About the first being the energy situation and also a small bit of the construction industry and why we actually need net zero energy, or what is zero energy in the first place, for some of you or some of us who may not know exactly what the terminology is or how you actually derive this. Then I would then focus into the details of the MEP requirements, focusing a bit on HVAC considerations, and then the electrical considerations, the PHE considerations, the architectural considerations, and then moving on to some case studies of net zero energy buildings. So this would be the flow. I think this is an imperative question that each of us probably understand, but probably it's also good to have a refresher of why is energy so important. I mean, we use energy today, I think, in every day and every second of our lives. And there was a time before the invention of the electric bulb that people did not know what was energy and what was light, probably. But in a very few years' time, I think we are all dependent more on energy as a necessity than as a luxury nowadays. And if you look at some of the stats, I mean, these stats are coming out of the EIA, which is the International Energy Outlook. They publish the energy stats every year. And if you look at it, EIA actually projects there is going to be almost a 30% increase in world energy use in the next 20 years. And if we look at this, I mean, why is energy important? I mean, there could be an increase in energy, and maybe we can generate more energy. But if we look at global news nowadays, I mean, there is a lot of stress on climate change. There's a lot of stress on polar ice caps that are melting. The rains are not being scheduled as they used to come, or the winter is setting in a bit late, or the summer is coming in a bit too early. I mean, all of these at the end of the day are interlinked as to how our lifestyle is changing with the world every day. So if you look at the sources of energy, I mean, if you look at this graph here, which gives you the world energy consumption by energy source, we are pretty much even today in the 2020s dependent still on non-renewable energy sources. I mean, research probably on renewable energy started 20, 25 years ago, but I think the kind of progress that we are making is not catching up on our need to consume energy. So petroleum, coal, natural gas are three things which are still ruling as to what kind of energy we typically consume nowadays. Again, going into projections of renewables by countries, I think India is still by 2040. We have to make a larger progress. Probably the imprint of renewable energy onto our energy consumption parameters still needs to take a much bigger peak. If you look at China, probably they started off somewhere in 2010 where they invested heavily on renewable energy, and now a large chunk of it, at least in relative percentages in China, they still go consumed from renewable energy. So India, I think, is yet to reach that peak, and in the long run, in probably 30 years time, I think with the kind of force multiplication that's beginning to take shape on renewable energy, I think this bar would certainly come much before than what is predicted here. But typically, India still is a coal producing nation, and we produce majority of our primary energy through the process of burning of coal. So coming to the energy situation in India, we all know that 60% of our energy sources comes with coal. I mean, it's always in the news on thermal power plants and why there is a power outage, why there is a, every time I heard it, I mean, I've seen it in Bangalore that every time the Raichur power plant goes down, there's a huge power crisis which affects Bangalore and cities similarly who are dependent on such power plant. That's again a coal-based power plant. Again, in Delhi, we saw the pollution itself. One of the reasons being the coal power plant, which is there in the center of the city of our capital. So coal itself is still playing a major role in our lives as to almost 60%. Hydroelectricity, of course, there are its own boundaries, but at the moment about 17 to 18% of the energy, primary energy needs of the country is coming from hydropower. And renewable is picking up. We are somewhere around 12 to 14% on the renewable energy source. So the aim would be to push that to about 25 to 30% in the coming future. But why is this so important? Again, if you look at current and future mega cities, the next 10 years, 80% of all the big mega cities are going to come up or spring up in Asia. and majority of them is going to come up in China and a lot more in India. I mean, if you see this map, it shows that the developing countries of the world are going to have their cities turn into mega cities in a very short period of time. So with this increase in the population, increase in the need for energy, I think the city's burden on energy is only going to go up, and there always is a cap as to how we can address these issues. So if you look at energy solution in India and how the buildings the energy consumption of buildings in India is expected to increase, we can see that the increase of the energy consumption in India is going to be much more than any other country in the next 20 years. That's almost about 2.7%, which is predicted for India as against 2.1% in China. So it's imperative that we as a country in the next 20 years look at what kind of energy we are trying to use, or what kind of buildings we are trying to design, and what would be their energy consumption in order to satisfy the bigger goal of reducing or having a reduced impact on the primary energy requirement from the non-renewable resources. Going to again the forecast of the construction industry, I know we have hit a small plateau, so to say, this year with the epidemic coming in, and the construction has frozen for some time. I think the industry has been feeling it, but I don't see this lasting for a very long time. Probably in the next 4 to 6 months, I think the industry is going to bounce back, and then we are again going to go up that construction ladder. And with the government opening up their investment opportunities for others, I think there is a big push on industrialization right now, which is going to come into this country in the next for the next 10 years. So if you look at our own past, I mean, if you look at 2005, we had about roughly 219 million households, and majority of them, almost 70% of them, was in the lower households category. And as and when it is going now, 2018, that 70% has come down to 43%. Urbanization is increasing. People are migrating towards cities, and the urban sprawl of India is only going to increase to about 70% in the next 20 years. That means to say 70% of the Indian landscape would be urban in a nature. So if you look at this again, 2030 forecast, the lower middle and the upper middle would then constitute almost about 70 to 75% of that segment. So with this needs an increased energy consumption. Again, this bar graph shows what it would be in again 2030. If you see, the rest of the rural would come down from 60% to about 44%, and that is only going to be a downward trend. So the rural areas is going to shrink, the urban areas is going to increase, and because the urban areas is going to increase, the footprint of buildings, the buildability, the built up square feet of buildings is only going to increase. And with the way we are building, we are construction buildings now, I think there is no second thought that majority of the buildings would be glass facade buildings. But the way we are actually handling the glass facades, I think we need to also take a relook into it. Because with glass, we allow in a tropical context or in a tropical region like ours, we would like the light to come into the building, but the heat would come in for free. So it always depends as to what kind of facade we would have, and then how do you take out that heat from inside the building in a more efficient and an effective way. I think Mr. Suresh was already mentioning that there was a time when we used to design a building with about 150 square feet or 200 square feet per ton of air conditioning, and now we are moving towards 700 to 800 square feet per ton of air conditioning. So even though there is more heat coming in, there are more efficient ways of removing this heat from the building. So we will have a look at some of those ways of doing it. Again, coming back to that question, what's the big deal? Let's produce more energy. So what if there are more buildings? We require an energy consumption. If I act as a devil's advocate to this, I would again say, what's the big deal? Let's produce more energy. But how do you produce this energy? So that's the question that needs to be asked. Today, we are still an import market, and our demand, if you see these blue graphs, is the demand of coal in our country, and the green graph shows us what is the production in our country. If we look at the last 7 to 8 to 10 years, the production of coal has reached a kind of a saturation in the country. I mean, we cannot produce more than probably a certain benchmark, but this demand will only keep increasing. So we will become more dependent on imports. So the collateral that we may have to pay for an increased energy use would be an increased import of energy or resources from the outside. Again, the second thing is the power bills. Power bills have gone up from day to every day. I mean, I haven't seen any particular bandwidth of number of years wherein probably my kilowatt, what I pay to my ESCOM or my electricity supply board has actually reduced. I've always seen it increase. The reason is very clear. Of course, if you need more energy, you have to pay more. So that again comes to a point. I think in Mumbai, the kilowatt what is paid per unit is almost about 12 or 13 rupees. In Bangalore, we pay about 9 rupees on the commercial front. And I remember this almost about 5 years ago, we were probably somewhere at 6 rupees on the commercial. So that again is affecting how much we may have to shell out for the energy itself. And the World Bank again has predicted that electricity demand in India will almost triple in the next 20 years. So this is what we need to focus on, how the demand will increase and how we satisfy that demand. Or do we need that kind of a demand itself, or can we generate power from natural resources? So that's what brings us or leads us to this concept of zero energy buildings or zero energy. What is zero energy? I think most of us have now heard of this, and also probably some of us have worked with this kind of a concept of zero energy. But for some of us, where this concept is new, the zero energy means that at the end of one particular year, if my building is consuming X amount of energy and it is producing Y amount of energy, at the end of 1 year, X would be equal to Y. Or the amount of energy that the building would produce on itself would be equal to the amount of energy that the building would consume. So at the end of 1 year, the amount of energy would be zero, or in effect, net zero. So that's what is the meaning of a net zero energy building. So how do we achieve this? I think it's no rocket science. It's not that like the building industry, we are doing really rocket science or higher sciences. Probably some design considerations, probably some out of the box thinking, probably some things which we may think works differently, or getting inspired by nature could help us do this buildings better. So typically, if we look at the strategies, we could pin it down into 3 points. One is how to the road to net zero energy or even net positive energy. The first point would be to reduce the energy demand. I'm not saying that we need to reduce our comfort requirements. I'm not saying we need to take the AC out of our rooms. I'm not saying we need to take our lighting out of our rooms or anything of such sort, but trying to make all of our equipment more efficient. So by doing that, we reduce the primary energy demand. There are 2 ways of doing it. One is, of course, passive design strategies, getting in the naturally available resources and whatever is available in an environment to use it to run our buildings. And second is the active design strategies, how we can improve our equipment or improve the machines which are used for running these buildings. Second is to produce that energy, what is required for the building on site through renewable resources of energy. And then third is you could either save that energy on site itself, probably using batteries or something, or you could also have it as a grid connected supply unit, where I could connect my energy producing unit to the grid which is already existing, and then again tap it off from the grid whenever it is required. So typical office building performance, if you look at this is some research data that I put together, And average buildings, typical average commercial buildings would consume something like 250 to 300 units of power per meter square on a yearly basis. High performance buildings, those are buildings with efficient technologies which are incorporated into it, and also monitored buildings which can actually control the energy sources itself where the building is consuming, would consume somewhere around 75 to 100 kilowatt hour or units of power per meter square per year. Zero energy buildings, the benchmark is a little higher. So the EUI, or the energy utilization index, in the zero energy buildings case would be somewhere around 35 to 50 kilowatt hour per meter square per year. So this shows that what are the benchmarks, or when we design a building, what kind of benchmark of energy we are trying to achieve. So based on that, the design considerations could be put into place. And this cannot happen if three people are not on board or they don't talk the same language. One, of course, is the design team, which consists of the architect and the engineer. The second are the contractors or the construction team. And third, which is the most important, would be the owner itself or the operating team, which is finally going to take care of the building or who is going to construct the building. So when all these three stakeholders are on board, coming to a common agenda, I think a net zero kind of energy building is more easily achievable. So getting into some of the parameters now on energy consumption. These are known to everybody. I think this is what we use in our everyday life when we are part of a project itself. On the HVAC front, we have the high side HVAC equipments. It could be the chiller equipment or the VRF refrigerant flow equipments. Then we have the AHUs, fans, pumps, cooling towers, and so on. Then we have the process itself, how the air conditioning is delivered into the space. Do we have an air side process or is it a water side process? I'll come to what the process is itself in the next few slides. And then is the control or the monitoring of the system. So how we can achieve effective control and effective monitoring of the system. Then coming to transformers or electrical loads, what kind of impact that would have, what kind of role do they play? And then what kind of role lighting plays. Then facades, glazings, roofs. Why are all these important? And the IBMS system, which would kind of bind the whole engineering system or the equipments together in order to achieve a more efficient building. So these are some of the parameters which would broadly affect the energy consumption of any building. I'm taking an example of probably a commercial building because that is where all of these systems would come into play at a larger level. So again, chillers, I think there was a mention that we have gone from a COP of almost 2 or 2.5 with the classic window air conditioners, which were there not very long ago, to about 8 COP. And nowadays, with the process also coming into play, which can be a water side process, the HVAC plant efficiency could be as high as 12. So COP of 12 probably 20 years ago was unheard of, and probably nobody could even believe that we could actually cross a COP of 10 on the HVAC side. But today, I think technology has developed very quickly, and we have moved towards these higher COPs, and 12 is also achievable today in the context of zero energy buildings. Of course, magnetic levitation technology has played a very important and a key role in revolutionizing the compressor itself of any chiller plant. And that is what has probably reduced the noise levels, the vibration levels, and at the same time increase the energy efficiency levels. So if you look at, I just took out this graph from one of the manufacturers, and what it says, it gives us the kilowatt per ton in the plant, in the part load, the capacity of a water cooled chiller. So if you look at the blue line, this shows the classic centrifugal type of chiller, and if you see the kilowatt per ton varies somewhere between 0.6 and 0.7 from the part load to full load. But with the magnetic levitation chillers coming in, we can achieve part loads of almost of 0.3 to 0.4 kilowatt per ton. So that itself gives almost a drop of or 100% improvement at a particular part load efficiency from an existing chiller to the next generation kind of a chiller. Then the second could be a VSD itself, which could be put on a compressor. So the VSD would give us a savings of about 25 to 30% on that itself. So a magnetic with a VFD could be a double energy efficient scheme on the chiller side. And HVAC system, why do we focus so much on the HVAC system? Because the HVAC system itself would take up almost 60% or 65% of the energy needs of a commercial. So if I can reduce or improve my HVAC system by 100%, that means out of the total energy consumption from the building of 65%, I'll bring it down to about 30%. So it's almost 100% improvement on my HVAC system. Overall, my building energy consumption or the energy utilization index would drop then. So the focus on the HVAC system is so magnific, and that is why improvements are always being trying to made on the HVAC system. Second is coming to the method of heat transfer. I think it's basic physics that we all know that the heat capacity of water is almost 3,400 times that of air. That means this much of water, as you can see, this small miniature glass will be equal to these two big bags of air. So if this much of water can remove the same amount of heat, what these two big bags of air can remove, then shouldn't we look at a way of removing heat from an indoor space using water rather than air? So that's where the process of air conditioning would come into play. And I think radiant cooling itself is not a new process which is being employed here. I think if you go back to the ancient monuments and also buildings that were constructed in India, you could still see that they had waterways in between granite slabs itself in the construction. So that could act like a buffer and it could take out the heat. Radiant cooling was used probably 1,000 years ago already, and probably we lost touch of that technology. But I'm happy to see that technology being brought back now and incorporated into buildings. So radiant cooling could be a process where we allow water to flow into the buildings or into probably the slabs or into the panels which are attached to the false instead of the false ceilings, or in the false ceilings itself, or in the walls itself. That could take out the heat in a much more effective way, which is 3,400 times better and faster than using air. So on the plant side, how would that affect? This is a classic plant. This is a normal chiller plant, which all of us have probably used at some point of time, where my chiller outlet would be 7 to 8 degrees Celsius and my inlet would be somewhere about 12 to 13 degrees Celsius. And my room conditions at 24 degrees would have an HU cooling coil getting in water at about at about 12 degrees and then pushing it out at about 13 to 14 degrees Celsius. Now with the radiant cooling kind of a system, the delta T between this will only increase. So my chiller outlet could be as high as 12 degrees and my chiller input could be as high as 17 degrees, because the water which needs to be running in these pipes, I don't have to have that coil temperature of about 13 or 14 degrees. I can have these water running temperature at about 18 to 19 degrees Celsius. So this 5 degrees delta T on the low side could affect my high side itself. And the chiller which is running at a higher inlet and outlet temperature will obviously have a better efficiency. So this is what I'm saying. It is no rocket science. It's all about using different technologies together and using physics into play in a much better way. Then coming to AHUs, fans, pumps, cooling towers, how do we kind of improve their energy consumption? Of course, we had the belt drive AHUs. Then we came on to the motor driven or the plug fans, what we called it, with the VSD system itself, which was the next generation. But now we have something called the EC motor. So that could be instead of my motor and my VFD, I have a small plug which is attached to the fan, which does the dual role. So I think in terms of power saving, again, You can see these graphs, it's about 30% better than the previous itself. So the EC fan would of course work more efficiently. This is the AC motor and this is the EC fan curve. So that shows that the fan would consume less power than an AC motor with a VFD itself. So these are new technologies which is coming into play, and some of us have already used these technologies. And in order to have a net zero energy building, I think we have to look at each and every parameter, each and every equipment, and each and every process. And once we improve each of these processes or each of these equipments, I think cumulatively we can achieve a reduced energy consumption and a more efficient system. Finally, the goal is to obviously achieve the net zero energy. So that would become easier for us. Then coming to the air distribution. Of course, we have been using the overhead air distribution now for long, but if we look at physics, the physics tells us that hot air rises up. So if hot air rises up, shouldn't we push cold air from the bottom so that it can get heated up from our the thermal plume that is created from our bodies, from our equipment, from the sensible sources that are available in the space itself, and then exhaust it from the bottom. So then underfloor air distribution could also be one of the techniques which could be used in order to achieve a more efficient air distribution process. So if we look at the overhead system, typically it's a mixing system. So it achieves a homogeneous mixture of air at about 24 degrees across the room itself. But an underfloor system would be a stratified system. That means my air, which may be entering at 20 degrees, or my grill temperature could be as high as 20 degrees, as against 16 degrees or 17 degrees in an overhead system, which would be the grill temperature. I already achieved a 4 degrees delta T on my grill temperature. And then as the height or the volume of the room rises, my temperature would increase. So my cooling zone itself need not be the full 10 feet or probably the 12 feet of space that my room would occupy, but it could be only 7 or 8 feet of space that my exhaust temperature could be as high as 26 degrees or even 27 degrees in an underfloor system. Whereas the exhaust temperature on an overhead system would be somewhere around 25 or 25.5 degrees Celsius. So these are also picking up now. I mean, underfloor systems are now becoming more accepted in the industry. I think there were a few challenges before, but I think now again improvements have been made, research has been constructed, and underfloor system could go in with a ducted or a plenum kind of supply system. Then demand control ventilation. I think this is very important in typically large commercial spaces where there are so many rooms and there are so many probably HUs, there are so many zones which are operating at different temperatures, different occupancies, different humidity levels, different activity levels. When we have a demand control ventilation system, we could achieve this in the same building. When I have, let's say, 5 floors or 10 floors or even 25 floors, one floor may be 90% occupied, one may be 10% occupied, one may be 50, and the amount of outdoor air that I need to condition and push into my building could vary across each floor or even across each room. So if my one room is occupied and another room next to it is having zero occupancy, the air only to this room which is occupied or having a conference probably could be supplied with outdoor air. So this is what shows how the demand control ventilation system would work, and it could be linked up to a CO2 sensor or even or a temperature sensor or a humidity sensor and so on to make sure there is an effective control on the system. So finally, we are looking at what? We are looking at plant efficiency. We have the low side, we have taken care of our probably the process itself, my HUs, my cooling coils, and on the high side, the chillers, the cooling towers, the pumps. Finally, can we have a very low plant efficiency in terms of kilowatt per ton? We have seen buildings with a higher plant efficiency of even 1 or 1.5 kilowatt per ton, but Today, there are also buildings which could be designed at a plant HVAC efficiency of about 0.5 kilowatt per ton. So if you look at that, I think we have come a long way in the last 20 years or so by bringing that 1.5 to 0.5 kilowatt per ton. And I think in the future, that is only set to go down. And 0.5 kilowatt per ton, I think it was unheard of, because a chiller itself used to consume about 1 kilowatt per ton before. So zero energy buildings would have such plant efficiencies somewhere about 0.5 or 0.6 kilowatt per ton. What is its effect on the electrical requirement? Okay, we talked about the HVAC side, we can do all of this, but then usually developers ask the question, we develop a building and we give it out, and there is a tenanted space, so why should we don't do the low side itself. So on the high side, what is our advantage? I mean, how does it benefit a developer who's probably putting a capital to the project? And whole, and when we are looking at bringing down the footprint or the energy footprint of the EUI itself, it not only helps the person who's occupying the building or the tenant, but it also helps the developer reduce his costs on the electrical side. So the leverage that we can establish on a zero energy building or a highly efficient building could be felt in a big way on the electrical side. How? Because we would have our load charts come down. For a building that may be having a business as usual building, which may have probably 4 transformers of, I'm just giving an example of 4 transformers. We may size it down. It may require only 2 transformers. So in that sense, the transformer capacity comes down. My capital that I invest on the transformer would come down, and consequently, the DG capacity would come down, because I don't have to invest more on the DG because my load chart itself is lesser. Then the consequent process would bring down my cable size, my bus duct size, my bus bar sizing, my panel size. So my panel size would come down, the amount of space that may be required for my panel itself could come down, my switchgear rating, my switchgear sizing would come down. And then very importantly, the electrical deposits that one pays to the ESCOMs or to the electricity boards when we take a sanction, that would come down, because my energy load requirement itself is down. So the deposits would come down. So that way it could lead to a overall capex reduction as well. Of course, the operational energy reduction is a guaranteed, and that could lead to a increase in usable space. So I could get probably on an electrical field, let's say 30 to 40% more usable space, because all of my energy demand has come down. So this is my collateral in order to develop a zero energy or a highly efficient. So just an example of a sample SLD. I mean, so like what I was saying, so these are the DGs. So probably these 3 DGs could become 2 DGs. Instead of 2 transformers, I could have 1 transformer, and so on. So all of these cable sizing would come down. All the switch gears, which I may be having my VCB here or my ACB here, or even my MCCBs, all those ratings could come down because my final load requirement has come down. So it's a cumulative effort that may that will come into play when we design such highly efficient buildings. And these bus bars, if you see, it's probably a 2000 amps. Now, if I'm trying to develop a business as usual building, this 2000 amps could go as high as 4000 amps, because each equipment of mine, probably even a computer, if we see, we have efficient computers which only use about 80 watts per system. And then there are non-efficient computers which probably use about 200 watts per system. So that itself shows that we could increase our efficiency from each point. So these things could come. And coming to the lighting, of course, there are different ways of doing it. One is the classical lighting, which we would provide in our everyday overhead or the false ceiling itself, or a zero energy building or a highly efficient building could go in for a concept called as task lighting. Now, the advantage with task lighting is it's only the task which is occupied could be lit. and the general space around it would just have a illuminance at a much lower lux level. So my task could be at about 104, and my general lighting or my corridors could be at as low as 100 lux. So my LPDs of most of the areas would come down. So before we used to design almost 1 watt per square meter, but now that has one 10 watts per square meter or 1 watt per square feet, and now that has come down to as low as 0.3 watt per square feet or 3 watt per square meter. So my LPDs would come down when my lighting efficiency would go up. So that would reduce my lighting road requirements also on the electrical side. So my feeders would have lesser cable size. My wires would be of a smaller diameter. So that would again affect my costing on the capex side. Coming to the glazing, I'm sure typically nowadays glazings are always double glazed, but there are few more parameters other than U value that one must consider when we select glazing. So I think we are all conversant with U value, which denotes the conduction heat gain that is coming into the building. There are other parameters also, like the solar heat gain coefficient and the visible light transmittance, that typically some of us try to go mild on. I think an SHGC plays a much bigger role because that is the transient that is the heat from the sun which is coming in through radiation itself. So while we look at U value, which is a lower, which could be the conduction heat gain from the frame and the glazing, it is very important to note that the SHGC of the glass itself is also lower, so that my transient or my radiant heat gain, which is coming into the space, is also minimized. But then we also have to look at the visible light transmittance, because the infrared side of the of the solar spectrum, we may want to reduce it, but that may also reduce my visible light which is coming in. So there should be a conscious reading of a visible light versus the solar heat gain coefficient when we select a glazing, and then the U value would obviously come into play. And it's always better to look at the combined system U value. Typically, when a glazing is selected, a very high performance and a very expensive glazing is selected with a very low U value, but then the frame that is made to fit this glazing probably would have a very high U value, and that would not give the necessary result in order to reduce my solar heat gain coefficient. So U values of frame and glazing need to be looked at when designing these processes. So U value nowadays are as low as 1.8 watt per meter square Kelvin, and SHGCs of glazing we could get as low as 0.2. That means only 20% of the radiant heat that is coming in from the solar heat gain is coming into the building itself. Then coming to the second point, which is the renewable energy generation. So we reduce the energy using all of these methods, and then whatever, I think solar has now become in the market. There are different ways of solar technologies, different kinds of panels which are available. There are some new technologies also in solar, which is the concentrated solar itself. So that could produce solar power as well as hot water for free, because when solar panels produce electricity on one side, the hind side of the panel itself produces heat. So producing hot water using this solar panels, you could get hot water for free. So this is one such unit. We also have BIPVs now, building integrated photovoltaics, where the photovoltaic panels, or it's a film, you could say it's a film, which are attached to the glazing itself. And there are different shades of it, 50% visibility, 40% visibility, 70% visibility. But that could also produce solar power on the glazing. So that those are the building integrated photovoltaics. Or some buildings also use wind power. So you could have vertical wind blades. This is from the Pearl Tower in Gonzhou. or also you could have these small windmills. These are 1 kilowatt windmills, which could be even attached to a house. So you could generate this local wind power at your spot itself. Or there is another technology, which is the earth air tunnel, where you can use the ground, which is a universal heat sink, to dissipate heat from the space itself. So the ground itself would not have a variation in temperature when you take the full year into consideration. And having the heat transfer from the ground to the pipes using an earth air tunnel could be also one of the concepts which could be used, which is at a very low energy consumption, but the dividend on the air conditioning side could be much higher. Then the new technologies are solar is also HCPV. So these are high concentrated photovoltaics. If you see the green curve, this is how the HCPV produces solar power on a single day, versus the red curve, which is the normal monocrystalline solar photovoltaic, which produces power. It almost produces double the number of units of solar power than a normal monochromatic solar photovoltaic. And HCPV, if combined on a dual axis tracker, it could also track the sun. So this is, I mean, these are photographs from one of the pilot installations that we did in one of the projects in Bangalore, and the results were very promising. It's only that the tracker come in selected sizes, and I think with solar technology going forward, I think this will become the in trend in solar technology in future. And coming to water demand, so we talked a lot about energy, but I think there is also a need to conserve water, because I think energy could be produced as much as possible, probably in a theoretical sense, but water cannot be produced as much as possible. So I think with all the green building certifications, there is a big focus also on water demand reduction. So aerators could be the simplest option of reducing flow on a fixture, or even low plumbing fixtures with dual flushing and low water consuming closets and sensor based water demand fixtures. Uh, Mumbai airport has waterless urinals. So I think that there was a time when we could not imagine how we could have a urinal with no water. But I think now even waterless urinals have become a good trend, and we can start reducing water from there on. I think one thing that we always oversee probably is the rainwater harvesting. And this is something that probably has been coming to our country, at least in India, quite a lot. I mean, we have been having rains almost every year. We have been hearing of floods in some places. We have been hearing of drought in some places. But then whatever rain comes in, there was an article some time ago, I remember reading it, that the Bangalore city, over a period of 1 year, receives as much rain as much as its water consumption for the whole city. So if we look at that stat, I think it talks volumes that a whole city as big as 10 million population could survive on the rain it receives every year. So I think rainwater harvesting is something that usually many of us overlook, and I think that's a very simple thing that could be done. We can just take the runoff from the terraces, the facades, the hardscape, the landscape, and so on, conserve that water and reuse it. So that could actually bring in a lot of free water itself for commercial spaces, where I see usually many tankers and tankers of water that come into the building because there is no good water that is available. So I think rainwater harvesting should still pick up, and I'm happy that most of the codes and the certification requirements need 100% rainwater collection in order to get zero energy or platinum kind of rating. Then of course reuse, I think that has already come in with for flushing, landscaping, and also for makeup water for cooling towers. So we could use that recycled or reused water for makeup water in cooling towers. Singapore, for example,
Dr. Rupesh,
there is yeah.
Your voice is, I believe, very low. So some of them, whatever they're saying, can you increase the voice? Maybe the mic, if you can bring it.
Okay. Yeah. Now is it better?
Yeah.
Is it better now? Yeah.
Yeah.
Okay. Okay. So coming to again, just this point of cooling tower, I think we need to focus more on how we can use this reuse of water or the recycled water into makeup water for cooling towers. Because nowadays in all commercial buildings or any large apartments, STP is mandatory. And with STP being mandatory, there's a lot of recycled water that is coming into coming into play, or there is a lot of recycled water which is available. And flushing and landscaping could be two sources, but if there is a cooling tower, we could also push that into cooling towers. So it's just that the water quality needs to be maintained, and if that is done, MBR technology today even promises water quality to be as good as potable. And I know many countries which also use recycled water as their potable water. So when it can be potable, I think we can do much in making use of this water for makeup water for the cooling tower. So again, coming to the zero discharge concept. So looking at making our building or our campus sustainable when it comes to water also. So making it a zero discharge campus or a building. So that would be the next thing. Then again, single stack drainage. This is another innovation that has come in. Nowadays are going to that with a positively pressurized system. Instead of the waste and the soil line, you only have one line for each of. So that almost gives a 15% reduction on the cost of the vertical pipeline itself. So that saves two extra pipes. One is the vent and one is the other waste line. So the soil and waste is combined in one line. So that's another thing for high rise also that could be put. And of course, I talked about the STP and the WTP, where my BODs and CODs and TSS should be maintained in order to reuse that water. Then coming to fire considerations, I think fire, I think today it has become very important part of our building design itself. Gone are those days where we would only do things for compliance sake and compliance benefit. But now I think safety has become very essential, and it is also being mandated in a very strong way. I think people have also realized how important it is to have safety. So pressurization fans, of course, are a thing with the NBC. We need to have the staircase, lift shaft, lift well pressurizations, and we need to have the jet fans. We need to have the axial flow fans, and so on. But when these fans are coupled with a sensor, it's not like the fans are always on, or it's not like the fans are always off, because the tendency is the fire requirement may need us to have the fans installed, but many buildings may not have these fans on. The reason being it may consume too much of energy. But from a safety point of view, I think these need to be kept on. And if energy is the issue, then putting a variable speed drive, trying to get the fans to operate at a level or at a location only where the pollutant is present. For example, in a basement, if one side of the basement is having parking and is having carbon monoxide, those fans can run at that optimum speed. And the rest of the basement, which probably may not have any occupancy of vehicles, could run at that minimum air changes per hour in order to keep some air circulation and from a safety point of view. So those can be incorporated and power could be reduced. So these are some of the and then coming to the integration part itself or the IBMS, where all of my systems will be integrated either on a free protocol or on a ubiquitous protocol or on an open network. I mean, BACnet has been now taken a precedence in becoming most used kind of protocol. But of course, there is Modbus, KNX, Lonmark. Many of these protocols are there where we could integrate these systems. We have our peripheral devices talking to the process level, and then to the communication level, and then to the HMI itself, where we can actually monitor and control all of these systems. Because putting these systems is one thing, but observing, continuously monitoring, and controlling all of these systems, I think, is the second challenge. And in order to achieve a zero energy building or a highly efficient building, we need to have a control on all these systems, and it cannot be done typically manually, and we need an IBMS system to operate in order to monitor and control the system. So I think these are some of the considerations. I would like to go into a few of the case studies in which we were involved. So this was a zero energy building in Bangalore, which was almost done about. I mean, it was designed about 8 to 10 years ago, and it was almost the first commercial net zero energy building in the country. So it was the showroom of Puma. I mean, they're undergoing a full renovation now, and they're changing all the systems. So it was a sports apparel. It's a small building, but at that time, almost 10 years ago, with the zero energy building concept itself kicking in, I think this was a highlight project which was developed in Bangalore. And if you see, for the first time, a BIPV kind of a system was used here for the canopy itself. I mean, most of the products here was imported because it wasn't available in India at that time. Now it's available in India itself. And the client was Swiss, so they wanted to use a lot of these concepts. So the walls were all porotherm walls with a very low U value of 0.21 watt per meter Kelvin. And the slabs were also GGBS mixed, and recycled steel was used, not virgin steel. My overdeck insulation was having a very low U value of 0.15. And if you see my glazing, U value was 1.8, SHGC 0.21, and a visible light of 6.6. They also achieved the platinum rating for this. This building achieved the platinum rating. And some other technologies which were used almost for the first time in this kind of setup was underfloor air distribution. There was a CFD model that was done in order to make sure that the air actually went, and to remove all the hot pockets in space, task lighting, and so on. So just coming to the energy parts of it, almost 41,000 units of power was required for the store itself. It was a ground, mezzanine, and first floor, so it was a small building. And the energy that the store generated over the period of 1 year was 42,000. So it was a slightly net positive building, but nonetheless, it was a building which showcased a lot of features, and it could also be proved that a showroom also could be done at a net zero energy space. So sensoring was also again with the lux level sensor, PIR sensor monitoring for daylight parameters, which is coming in, and LPDs of almost about 3 watt per square meter. Then this is another building which we were part of the design. The 342 building. I mean, all of these buildings you could also Google for more information. A lot of the material and a lot of the technical parameters are available online. It is published online. So all of this, what I'm showing, is already in open source and in open space. The 342 building again was a building which was a almost, I mean, I would say it's a high performance building. It was not net zero energy, but there was a lot of parameters like sensible cooling was through radiant cooling, and there was an integrated facade with an underfloor air distribution which was meshed into it. In this building, there was also a false ceiling, and the false ceiling itself acted like the radiant panel. So it was an active false ceiling rather than a non-active false ceiling. So all of those tiles, what you see here, those were radiant panels. So that would be my air conditioning system itself, which almost achieves 700 square feet per ton in terms of the heat load requirement itself. So coming to some of the stats, the target was achieved to about 65 kilowatt hour per meter square on a yearly basis. So there was a EUI consideration which was given here, and EUI of 65 for a tropical setting was quite low. From a business as usual was about 176. So these were some of the things. And then of course, I think some of us may have already studied about this project, the River Tower in Gonzao, which was a LEED platinum building, and it almost achieved net zero energy. So that would, if it had achieved the net zero energy, it would be the first high-rise at that time, a very large, a very high-rise building to achieve net zero energy. But nonetheless, I think it's a good case study to see how it could be a very, very energy efficient building, being 71 stories or 300 meters in height, having a built-up area of about 15 lakh square feet, it almost achieved about 50% energy saving than business as usual buildings in the region. Again, if you look at some of the parameters or design considerations which were used, underfloor again comes into this building air system. There is again radiant cooling which was used. These snapshots a sense of the radiant cooling panels which were used as a part. Again, you can see this is a false ceiling which has been converted into an active false ceiling. And this shows the wind power running. So this is my wind turbine which is running in order to produce that energy. If you look at operating energy of this building, we were involved in some audit parts of this building. So we have this data basically from the building. So on the design side, it was almost 55 kilowatt hour per meter square per year, which was targeted, and that would achieve net zero energy because that is what these wind turbines could produce. These wind turbines could only produce power which was equivalent to 55 into 15 lakh square feet of energy per year. But what was achieved was about 89 kilowatt hour per meter square. So I think a building of this size, 89 kilowatt per hour per meter square, is quite an achievement. And buildings of this size also could aspire to achieve net zero energy. Then we have Infosys campus here. I think that's the numbers talk for itself. Parameters in 2008-9 were these, and in 16-17 were these. So on the EPI side, it was almost 63% lower. Again, it's not net zero energy, but very highly efficient. And on the EPI, if you see from 200 units of power, the EPI came down to as low as 75 units of power per meter square. The AC was 350, came down, went up to 750 square feet per ton. The electrical design came down from 6.5 to 3.5 watt per square feet. I think for Infosys, it was useful because they run their own buildings, and on 1 million square feet of infrastructure, the conventional design was 6.5 megawatt. On the electricity, came down to about 3.5 megawatt. Transformer capacity reduced again from 7.5 to 4. DG in turn again coming down. And if you see the annual energy consumption came down from 20 million units to about 7.5 million units. So overall, the change in about 10 years time was 51% in per capita reduction on the energy side and 46% on the water consumption side. So the water consumption came down by almost from 3.2 to 1.7 KL per employee. So that's a per employee kind of then yeah, this is one more. We were a part of this in Tokyo. It had a total floor area of almost close to about 1 lakh square feet or 8,600 square meters, 8 stories above the ground and 2 basements. There are again nearly net zero building itself. Again, some of this absorption refrigeration system was used because there was also heat which was made available, which was linked to a solar panel plant itself. And then there was also a earth to air heat exchanger which was put, and there was a desiccant unit in order to again, radiant cooling is a part of this project. I'm just saying that many of these net zero or nearly net zero energy buildings have some things in common. One of it being radiant cooling, second being underfloor air distribution, and third being the process itself, how it is. And so this gives us where it stood. I mean, on the net zero energy building scale, which is a globally accepted. It stood at this point, almost ZEB ready. So, in summary, I think this is what I thought we could have. We need to have the baseline first, and then look at heating or cooling as things that we need to work on, and then lighting, and then how we can look at the process. So bringing the baseline down is the first aspect, and then the second aspect would be to generate that energy that is required by the baseline itself. So that would achieve a net zero energy building, or this is the process which could probably have achieved a net zero. So this is what I had. I thank you very much for being a patient listener, and if there are any questions, I would. Thanks, Dominic.
Oh, thank you, Dr. Rupesh. It's very highly technical presentations, and I could see many responses for your presentation, appreciating your knowledge on the subject. And there are a few questions that has been raised. I will take it forward. Can you unshare this, Rupesh?
Yeah. Yeah, sure.
So we will take.
Also, I mean, if 1 minute, Dominic, in case I'm not able to address all of your questions, or if you have questions later on, you could also email me on the email ID that is flashing on the screen right now. So I could be able to help you out, or we could work at a later stage in addressing those questions. Thank you. Yeah, I'll unshare my screen now.
Yeah. So we will, after hearing out from Mr. J.N. Bhavani Prasad for 10 minutes, I would like we will go.
Hello. Am I audible? I'm not able to hear this one clear. Group science was clear. Next is coming with breaks. Hello. Right.
Can somebody read out the questions so Rupesh can answer?
Bhavani Prasad is going to speak now.
Hello.
Silence.
Dominic, I think is Dominic Prasad able to come online? Dominic, are you there?
Hello.
Is there?
Sir, Bhavani Prasad, sir, are you there?
He's there. He's waiting for your.
Hello. Okay, sir, Suresh sir, should we move on to the question answer?
Yes, you should. It's already 12:35. Please. You should. You ask a question, then we'll answer.
Yeah.
Some can be done by Rupesh, some can be done by me, some by Bhavani
Yeah.
Prasad.
Yes.
I can take question
Yes.
number 1 on U value. I can take Thomas Verghese question on NBC.
Okay, sir. I will move on to the first question. That is by Thomas Verghese.
Yeah.
Why USBC, USGBC, and IGBC does not have any glass U value standards? Over to Mr. Suresh.
Thomas Verghese, misinformation, disinformation, lack of information, and not the right information. All our rating system of IGBC for the 26 rating systems, we adopt these particular things of the right U values as well as the R values required for glass and the fenestration with various situations of the clear glass, opaque glass, vertical fenestration. In every case, that's an important thing that we do in our design that we have for the envelope design, and also the type of things for the walling and roofing, so that the solar heat gain coefficient is covered. So the U values and the R values are the most important tools that we adopt. So to say that IGBC is not using, obviously you're not aware on that. So possibly if you go into the rating systems of each one of them, you'll get an idea how this has been done. And incidentally, we are entirely in line with the National Building Code Part 11, which is sustainability approach to the whole built environment, where U and R values have been put. So therefore, the things that comes important are the energy performance index, the solar heat gain coefficient, the U value, the R value for different situations of different assemblies of glass, etc. So the answer to you is that what you thought is not the right situation, we are using it immensely. And then we also link with the document, not only the National Building Code Part 11, you're also having another segment called the solar glazings for the building, which is the new Part 6, Section 8 of the NBC. That along with Part 11 is used. And the Energy Conservation Building Code 2017 brought out in 2018 really gives the values in respect of each one of the situations for the roof, opaque external wall, vertical fenestration, skylights, and the building envelope. If you see those particular details over there available on pages 26, 27, 28, 29 of the ECBC document, which we utilize as our base document, you are able to get information for these in a large way. So therefore, the answer is available. We are using it already. I'm sure even the US Green Building Council must be utilizing that for them. Otherwise, how will you have the performance coming? How will you ensure an envelope of a building which has got wall around, roof around, which has got fenestration there? You want the light in, but not the heat inside. So the solar heat gain coefficient is a very, very important component. And all these things are covered only by the right values of those materials, namely body material or glass glazing material with the right U and R values. Can we take the next question? Can we take the next question, Dominic?
Yes, sir. Yes, sir. The next question is from Senthil Kumar. May we know how is the AT and C losses faring over the period of time in India? I'll repeat the question.
Yeah, that should be taken by either Rupesh or one other. I'll take the first and last question. Again, one more question. NBC is coming later towards the end. I'll take that. Okay.
So we can skip this question. AT and C losses faring over the period of time in India. Rupesh, anything on that?
I think Mr. Bhavani.
Okay, we will move on to the next question from Bhavesh Mehta. What is the cost per TR for radiant cooling? Can we apply this technology for warehouses with 12 meters ridge height? Which type of flooring is required considering material movement? Also, if we need cooling from the bottom. This is from Reliance Industry, Mr. Bhavesh Mehta.
I think first one is what is the cost per square feet for radiant cooling? Sir, the cost for radiant cooling right now is the same. The low side cost. I'm talking about the low side cost is the same as your ductable ducting cost itself, because all radiant panels or even the tubes for that matter is being now manufactured in India. I agree with you. If you have been looking at these radiant cooling costs, probably 3 to 4 years ago, we used to import all of this mostly from Germany, and it used to cost almost double. But right now, all of these tubes, all of the panels are being manufactured in India, and not by one manufacturer. There are 2 or 3 manufacturers who do this. We are already using that in some of the projects that we are designing, and the low side cost is the same. High side, of course, is similar to even if you have radiant cooling or not. I think the high side is a different matter. The cost almost would be the same again because it's the high side. But yeah, the low side is the same, sir. And I think your second question was 12 meters height, if I'm not wrong. Was that?
Yeah, 12-meter height.
Height.
Yeah.
Warehouse, like warehouse. It's talking a warehouse.
Yeah.
Higher story heights.
Yeah. So higher heights. There are a few projects already. Warehousing itself, which has been done. I have seen warehouses using radiant cooling panels, not because warehousing usually go with a PB kind of a structure, and so these panels could be attached even at that height, and from that height, cooling load could come down. But only with the ceiling, it may not be achievable. We may also have to have a part of my side PEB is also to have the panels. So it is possible, sir, even for warehousing at that height. Then the third one, can you refresh me, Dominic, or what was the third point?
Which type of flooring is required considering the material movement? Also, if need cooling from the bottom.
Okay.
Type of flooring
If you need
air throw from the bottom.
Yeah.
Okay.
So if it is underfloor air distribution, so it's cooling from the bottom. These could be embedded also into concrete. So you could also have a concrete flooring I'm sure in the warehouse there would be heavy movement, forklifts will be there, and there would be heavy equipment which is moving, and concrete probably would be the best flooring that you may be putting. So these underfloor systems could be also embedded into concrete. It would be a kind of a ducted kind of a system, and you could also have it precast. So even in a precast concrete, these systems could be embedded. Otherwise, also tiling is possible. So it could be embedded with tiles, and for other spaces, even with carpets.
So moving to next question from the Senthil Kumar. How would be the distribution of cool air in a room from underfloor system as compared to overhead system?
Good question.
Yeah, so the room air distribution would be stratified in terms of an underfloor air distribution, but in an overhead air distribution system, it would be non-stratified but a homogeneous system. So in an underfloor system, at my grill, you may have 20 degrees, and at my return grill, I'm sorry, at my supply grill or my supply diffuser, I may have 20 degrees Celsius, and my return grill or my return diffuser could have as high as even 26 degrees. But my homogeneous system or the overhead normal system would have about 16 to 17 or even 18 degrees Celsius at my supply diffuser or grill, and my return would be at about 24 or 25 degrees.
Well, thank you. I think one of the panel member, Jaisima Narsimhan, wanted to give you a project. So that's a good news for you, and he would like to interact with you. So I will forward that later. Again, I think Senthil Kumar is asking a couple of questions. Just I'll quickly read this. As we try to become more energy efficient, noises like harmonic and EMI are generated, and they have their cost and size impact like higher K-rated transformers, AC and DC chokes, active and passive filters, etc. In your design experiences, how would you tangibly compare the cost and space benefit of energy efficient design with regard to electrical system mainly?
Sir, I think harmonics, of course, is a major thing which we experience in design, especially with ELV systems being there. More so also in even data center projects where my low voltage and also electronics are playing a major role. And of course, filters would take care of the harmonics which are generated. But in terms of energy efficiency, I think the harmonics part would be more on the operational side. And if the filters are not there, of course, it would lead to losses on the transmission itself. But I don't see, I mean, if it is a data center project, then we need to have these filters if it is if the building is energy efficient or not, or even in a place where it has high electronics, like probably a PCB manufacturing plant or a chip manufacturing plant. They would have higher ELV loads, and harmonics would play a major role. So the filters would come into the design nonetheless. The energy efficiency part would come on the other equipment itself. So the filters are a given thing. So I think energy efficiency and filters, I wouldn't say because my building is becoming more energy efficient, my cost would go higher because my electronics component on my equipment has become higher. So I think the cost would be very marginal. It's probably less than 5% of the cost that would be on that. But the other side of cost saving is probably of a much bigger magnitude.
Okay, I'll move on to the NBC questions from Thomas Varghese. I think our Vice Chairman of NBC may be able to answer why NBC doesn't.
Please read the question.
Why NBC doesn't say crack of door of pressurization? Every state have their own fire norms in spite of NBC document. Nobody has the guts to talk to fire officers to go to God with NBC. NBC committee should take into government officials. So he's saying that NBC should the team of NBC should talk to the government, state governments in implementing those standards.
Yeah, I got it. Can you hear me?
Yes, sir.
Yeah, I think Thomas Varghese, the doubts are misplaced. As far as the National Building Code is concerned, Part 4 on fire protection is one of the finest document where he talks in terms of all the issues on movement of not only the fire as well as smoke to go, and all these cracks and related systems which are all to be plugged, especially when you pressurize all the area. One of the most important, it should work well. So those provisions are there in the document. And for information, the 2016 version document is still having so much amount of what can I say, mandate. Even though the whole National Building Code is recommendatory guiding, Part 4 of the National Building Code has really become mandatory, not because the code itself is mandatory, because that document has been adopted by all the state government fire services under the Fire Services Act over there. This is the document that is used, including the Standing Fire Advisory Committee of the Ministry of Home Affairs of the Government of India, under whom all the state fire service teams are working on, have made the National Building Code Part 4 as a compulsory document for use for evaluation. Nobody is scared. Why should we be scared to talk to any other fire people? They are not some, what can I say, terrorist or something like. They are as good professionals to deal their particular job of fire protection. What is required is that the people, they are a regulator. They are also a service provider to come and help you in fighting the fire. That is their role. What is required is the builders, developers, architects, engineers, fire protection consultants, MEPF consultants, each one of us are on the supply side. So on the supply side, all those people dealing with the generation or development of all those buildings, if you can make that fire safe, I think Rupesh also talked in terms of the fire safety aspect. All those comprehensive provisions are to be adopted. What is needed is that our lead builders as well as the lead consultants or architects and civil engineers and mechanical, electrical, plumbing, firefighting consultants have got to be fully geared of the provisions there and utilize that. And once you submit a document to a state, after all, local bodies are not able to pass judgment. So they go to the state fire service for getting a NOC from the fire department, whether provisions incorporated are good enough from fire protection, fire safety, life safety. If that is so, then only the building permit is given, and then the completion certificate for the building has to be submitted. These people again jointly inspect to see whether all these are maintained, all are installed properly before an occupancy certificate is given. And the latest is that's not enough. It is not showing everything on paper. It is like next one is to complete it. But after the building is completed, after it's commissioned and is occupied, and now building comes 1 year down the line, 2 years down the line, does it over? All the concerns, everybody can run away, and no, it can't be happening. Therefore, I told part 12 and assets and facility management, and especially on the fire side, does the sprinkler work, your wet riser rise, your dry riser work, your detector works, or your alarm system works, your water is available, or what is the state of health of all those installations are continuously being watched through what is called fire audit. As a matter of fact, there was a good session that was done by out of the same group there that you have, and that was also indicating the issues on fire audit will bring the state of health of what the installation is all about. How does it perform rightly? Is the all the issues of pressure working or not working, or in the sprinkler can it work, etc. is coming. And also is bringing in the new concept of the renewal certificate to be given to building. Fire protection point of view, the renewal certificate is coming. Some do want it once in a year, some wants it once in 3 years. It all depends upon how well you're able to operate and maintain your system. So therefore, it brings in a very important concept of life cycle costing of capital costs for installing all these installation and the operating costs required to keep it running. And if you're able to do that well, it will perform well. And therefore, I would request you to kindly see the clause provision, and all the fire departments and fire service department and the municipal commission, municipal corporation, city engineers are looking up to the provisions of the NBC fully for following it up. We have got excellent relationship with each one of them, and I'm glad that you have already identified that we require this to be sensitized more with the fire department as well. We shall be taking it forward further. Thank you.
Sir,
Sir, sorry, sorry for interruption. Thomas here. See, why this has been I put in this question is because I've done a job in Delhi. As per the NBC, we are given the air changes for 8 and 12 for the fire mode and the normal mode. But when we went to the local body, they said I want only within a ducted system with the 30 air changes. This is, I'm telling you, 1 year back.
Yeah.
This is a situation is happening in the Delhi. I have experience for this one. And if you go to the Hyderabad, you go, there are different people.
No, what's happening is perceptions of the Delhi fire service also one of the finest one, with people like Deri, Mr. Sharma, and as well as also Gopalji was all, Sharmaji were all being the fire service directors, extremely competent people there. But it is quite possible in your particular one case, there must have been some amount of this thing. But then you could have immediately then and there brought the provisions of the NBC and latest provision of 2016 on the air changes. There's a very major change that has happened. You're referring to which version, Thomas? 2005 version or 2016 version? Thomas, are you hearing? Hello?
Hello?
Are you hearing? Are you referring?
Yeah, I'm hearing, sir.
NBC 2005 or 2016?
2016, sir.
Yeah, 2016 version covers the provisions on the air changes very clearly, and it has got to be adopted. There is no other alternative to that.
Correct, sir. Absolutely, you're right, sir. I'm telling based on that one only we have submitted the document, everything. They said no, as per local bills, I want only 30-year changes. So finally we changed everything, all the totally design was changed to 30-year changes. We submitted and we got it approval finally, sir.
It's one of those things, sometimes what they catch up a little later. some of those other fire services like Maharashtra Fire Service, Karnataka, Tamil Nadu, they are all extremely savvy about latest provision. They participate very well. Namesh Shivayam, who was earlier Tamil Nadu, he is the one who presented on the
Correct, sir. Yeah, yeah.
work here in this in our
Maharashtra,
own.
sir, I'm working for Maharashtra in Pune and all. Maharashtra, they are very good. Karnataka is good. Hyderabad, at least they are going only based on the NBC only.
Yeah.
And if
Lot
any
of
some
the-
changes required, they will tell us, sir. That is what by the Hyderabad.
The short point is that because time is not there, short point is that all of them adopt NBC Part 4 Fire and Life Safety as the document for fire protection. There is no other document in the country available for utilizing, and that is why on this particular document now it's being really become mandatory. The builders, developers, architects, engineers are going through each provision with the microscope, each line, what the contents are, and therefore, as I said, 2016 version has come. We got a lot of useful comments which has come on that. And the NBC is a dynamic live document. It's not dead document. Once it's gone, it's continuously under review. And you will very shortly see some of those good experience over the last 4 years that has been generated through various seminars that has been organized on Fire Protection 1. You will get the latest version coming on. If not, the NBC itself will not come revision. At least the Part 4 fire protection will bring in some amount of positive changes that will be coming on that to take care of that. Kindly let us leave it at that. But I think the aspect is that increasing level of awareness, capacity building, training program, sensitization program is necessary for not only the developers, the consultants, but also the regulator who is sitting on the other side of the table to pass judgmental view. I take your point very positively. Thank you.
Yeah, we have a very short time and we have another 8 questions to be answered. So, we'll move on. One important, very interesting question. Purva Shah is just asking why urban has maximum disasters. Even the developed countries are the maximum problem, like example COVID-19. Just out of context to the subject. So one question: why urban cities have maximum disasters, not rural?
If he's talking of the natural disasters like earthquake, hurricane, flooding, landslide, and related one, I think this is a good question that you asked over there. If you really look into the why, even though the National Building Code has got provisions in Part 6 to deal with all situations, high winds or cyclone that come, the earthquake zone that are there, and provisions over there. But if you look into most of the building bylaws of the municipality, there is no one word of disaster anyway. That it should be earthquake resistant, it should be cyclone resistant, it should be flood protected, it should be landslide protected. Why is it that all the landslide problems are happening? Because not one word of disaster is there. I would like to give a good example, possibly that will demonstrate. In 2001, we had the January 26th, we had the Gujarat earthquake. In less than 1.5 minutes in the morning, school going time, we had the massive earthquake affecting the 8 districts of Gujarat, from Kutch to Rajkot to Ahmedabad, zone number 5, zone number 4, and zone number 3. And in less than 1.5 minutes, around 13,500 people died and 8 lakhs houses, rich man, poor man, low income group, everybody, all the houses brought down to ground zero. 1 month from then, in February 2001, in Seattle, and that is actually on the fault region where the Bill Gates city, they had an earthquake which is bigger than what we had in India. And can you believe there was only 1 person died, that to a heart attack, not a single building collapse. Why? Because the Seattle Building Code and the whole areas in those particular area, they've got clear provision that this particular project, this is coming in zone number, so-and-so zone. So all the buildings have got to be planned, designed, and built using earthquake resistant features. Full stop. So the architects, the engineers, the builders, and the local body all are talking the same language. There were no building collapse. Only 1 person had a heart attack. Whereas here, 8.5 lakhs of house, because not one word was there either in the Rajkot bylaws or the Ahmedabad bylaws or in the Kutch bylaws, everywhere. Even now it's not there. I'm actually now speaking about Trivandrum. We got so much amount of problem. Even now, the Kerala municipal building rules or Panchayat building road has not one word of disaster on what needs to be done to deal with all the disasters. So one of the aspects is therefore we have solutions available. we need increasing level of awareness on this and also enforcement on that. For the regulatory regime has got to put disaster as an important component, putting over there as compliance on that. Flooding is a very major area. Flooding and related issues are another major area coming. So we don't have too much time. This is a topic. Disasters can be one of the topic you can take for a 2-hour discussion. But I think next time, but let us stop it at that. Why is it happening? Is because the density, the urbanization is coming in a large way, contribute to 78% of India's GDP and occupy only 4% of India's landmass. So densification and tall buildings are coming without proper regulatory framework to deal with that. So buildings are coming without the right level of protection to deal with all these disasters. And if you do that, there would be so much. An earthquake will not kill anybody. Earthquake doesn't kill people. It's a badly designed building, badly constructed building and maintained building, which falls on the people and you're buried underneath that. Suppose you've done all those right level of rigid structures to flexible structures to deal with the lateral load, like the wind load from above the ground and earthquake load below the ground, you wouldn't have this problem on that. So what is required is increasing level of awareness. There are good builders, good developers, good structural engineers, architects being brought in over there. They do that. But it's those cases which are 80% case which are in the general realm, they don't adopt. The top 20% will always adopt, they stand well. So let us leave it at that, okay?
So we need to move on very quickly. Yeah, Rupesh, Dr. Rupesh.
Yeah, I just wanted to add, one of my experience. I mean, this was concerning one of the projects. I wouldn't name the project, but it had a fire, and the audit after the fire, I mean, of course, had a lot of capital loss that happened. And after the audit happened, the design itself was perfect. It was as per the codes and regulations and all of that. And then when they went into looking as to what was the reason, the fire which originated in the basement and almost gutted down 50 to 60 rooms on the top floors, the one reason which was pointed out was all the pressurization fans were installed, the lift well pressurization staircase, all of them were installed, but they were switched off. So that's a classic case when
I gave the answer just a little earlier. If you had done the periodic check on those, particularly on maintenance issue, along with the audits coming at it, not after the whole fire doing the audit. You do regular audits coming on that, then you will see what systems are working or not working. You should see the document in the NBC, not only part 4, you kindly check into part 12 on assets and facility management, on firefighting installation, what is the checklist that should be done every month or once in 15 days to see systems are working or not. Many cases where you say sprinklers are there, if your sprinkler doesn't work, water is not with pressure there, when the fire comes, it doesn't perform. So you're told exactly the same situation that or many exits that planned, completed, occupancy certificate given, but later on, they block the very paths for going out. So therefore, these are details of post occupancy certificate. When different clients come on different floors of the building over there, changes happen in a building than what was originally given over there. So you got to keep.
I think from the energy perspective, the amount of energy that one would save by switching off all of these fans or safety equipment would be negligible when it comes to the collateral damage it could cause because of it's not working. So I think, yeah, that's one energy point.
That's a good point. You say that, we meet all these standards and codes, and to save energy, we switch off the entire critical services. Then an accident happens. So yes, you need to really check whether you need to compromise the critical services. You need to be switched off to save the energy. Anyway, we'll move on to Mr. Anil from Mumbai. He's saying, if glass facade buildings are not energy efficient, then why continue with this trend?
Okay, I'll take that question. I don't think glass facade buildings are not energy efficient. I think if that was the message which one got, I think that's not the right message. Glass facade buildings, if the glass is selected correctly, then it could be more efficient. As a matter of fact, glass is also sustainable because it is recyclable. If you take concrete, for example, concrete cannot be 100% recycled, but glass can be 100% recycled. So what I'm trying to say is glazing or glass which is selected should be selected judiciously. Now, if it doesn't make sense if I have a tree cover in front of my glazing, or if I have an urban farm in front of my glazing, I go in for a double glazing. Then I can go in for a single glazing. But if I'm going in for a west facade, and if I'm going in for a single glazing, and then I'm having an air conditioning equipment taking out 20 tons of loads rather than taking out 10 tons of load, then that glass may not be usable. So there's a way of selecting glass, there's a way of selecting the fenestration, and all of these technical parameters should be considered in order to select these systems.
If I may add to Rupesh's point, that information that glass fiber is not energy efficient is not right. So you can make it. If it is badly designed, of course it will definitely be inefficient. Well, this is where the answer which I gave earlier to the very first question Thomas was asking on the U value and related things. So therefore, all these important solar heat gain coefficient, U values for the glass for different types of assembly, single thickness glass or double walled one, or putting the cavity in between there, and also to put the right window to wall ratio, as well as the other features to see heat gain is reduced to the least over there, the type insulation to be done for the walling, roofing, and other matters becomes an equally important component. As a matter of fact, I did tell you that in addition to that, NBC 2016 is the first document in the world wherein glass and glazing has come in Part 6, Section 8. I'm not sure whether you're aware of it or not, where the whole thing comes as an envelope, so it becomes a structural element there. So how do you deal with that particular component? And then based on the feedback coming from the fire department, also put a 10% opening in the glass for things to for smoke to go out, or the firefighting people coming from outside to get inside, and other related components are also brought in over there in the glazed building there. So therefore, kindly look at three things: Part 6, Section 8. Number 2, Part 4 of the fire protection component, as well as the information Part 8 building services, and the last one, Part 12 on the assets and facility management. If you read all the three together, and including Part 11, sustainability gives all the U values and the R values, which I mentioned, it is available being used over there. Thank you.
Let's move on to let's
I
quickly.
just showed.
Yeah, level
Dominic.
Just showed the Pearl River Tower. The Pearl River Tower, which I showed, is a fully glazed building. It's a 71-story fully glazed building, and it achieved a very high efficiency of 85 kilowatt hour per meter square per year. So we can achieve energy efficient buildings which are fully glazed. There is no issue.
So Mr. Bhavesh Mehta, from the Reliance Industry, is, I think, touching the question on Upar Cinema tragedy and why 30-year changes. I think Bhavesh Mehta is want to say a few words on that.
Yeah, thank you, Mr. Dominic. See, this Delhi issue, we have also a number of malls in Delhi, and I was involved in this MOEF and approval for this thing, and especially in Delhi because of this Upahar cinema issue. Everybody knows the CFOs are very much stringent and very much reluctant. Even they will not allow you jet fans also. Okay, they want a mechanical ducting, they want a fire air change as per the 12 and 18, so 30 18 per hour, and they are very strict. So except Delhi, wherever we have the malls across the country, Reliance Mall, we have done jet fan and conventional fire fighting systems or fire exhaust, smoke exhaust system in case of fire. So it's only a Delhi. I agree with you, Mr. Varghese, that Delhi is a stringent. So this is what I would like to say. Thank you very much, Dominic.
Oh, thank you, sir. Thank you for complimenting to the question of 30-year changes. So there is a question from anonymous attendee. Thank you, Rupesh, sir. How would be 20%? Is that fan energy or a plant energy? I don't know this question, but I'm asking you if you can understand. He's saying, how would be?
Yeah, this should be on the plant level. This would be on the plant level.
Yeah, how would be 20%?
Yeah, so it would be on the delta T's across the grills, and then the second would be at the AHUs, and then the third would be at the plant level itself. It could be a chiller or a VR, either of the system. So it's basically matching the delta T's.
Okay, we'll take two more questions before we close. It is 1:09 now, so we'll take two more questions. Rajendra Kamble saying, in new projects also at NCR, CFO asked for ducted ventilation and not jet fan? Any specific reason? I don't know whether anybody can answer. He says a CFO is asking for ducted ventilation, not jet fan.
What building is that?
In NCR, a new project.
What is that? What building is that?
NCR, I don't know whether it's a mall or a parking. He's not answering.
I think depends upon the use of the building on that. If you're able
Probably
to
a
get
parking.
It must be a parking, sir.
Yeah. Would you like to? Of course, those areas are always, if it's parking, especially if the basement, 100% sprinklered. That's a requirement. You have to have 100% sprinklered facilities over there. From that particular point of view, what you're talking is the additional circulation for this one exhaust and related one is talking about. I think if you're able to get details and send a mail to us, we'll be able to answer on that on part 4. You have the email ID of the gentleman? What's his name?
Yes, sir. We have that. All these questions that is posted is all recorded, and we will individually answer to them. And there are few more questions that we will not be able to take.
Yeah, if it is a design issue, you can just we can send an email. We can help you answer that.
Yeah. Your comprehensive provision available on this, especially on basements, right?
So I would like to post this question to the panelists later, and as and when you feel convenient, probably you can answer to them. And we had a record of 420 participants for this webinar, and very good interactions, and there are a lot of many complimenting our speaker knowledge and the presentation, and many of them demanded that they need PPT. I'm requesting Rupesh, if possible, maybe the trimmed one, you can share it so that I would, when in my thanking letter, it will reach everyone so that they can refer. And lot many people are asking the telephone number of Mr. Suresh. Again, I will be, with his permission, I will share it later. And maybe the email ID, I will share it later, sir. So I would like to thank you, all the participants, for coming forward, and please give comment if you need any specific subject that we need to address in the next webinar. We will love to bring it every Saturday. All my colleagues here and team, we are doing free knowledge series. So if anyone feels that we need to cover certain important subject that is not covered by other webinars, we will love to do it. It's a free knowledge sharing. Please keep commenting. Please give some suggestions to improve upon our webinar. I want to thank the senior member here, Mr. Bhavani Prasad. Unfortunately, he is in poor network, so he is unable to speak. Otherwise, he would have contributed a lot. And I want to sincerely thank Mr. V. Suresh, the Vice Chairman of National Printing Code. He never said no to me till now, and I hope he will continue to be part of most of our opening remarks. Thank you very much, sir. God bless you for participating in this session. And Dr. Rupesh, the young man, I'm sure he will stand by me as we move forward, and he will continue to share his knowledge. Thank you once again, everyone, all the participants. I will share you the video, and if a speaker shares the PPT, I will also share that to you. Thank you very much. You have a wonderful day. God bless you. Stay safe. Thank you very much.
Thank you, Dominic. Thank you, everyone. Thank you.